Students, today in this class we are discussing about the structure of atom. So we'll learn in 9th class about subatomic particles like negatively charged electrons, positively charged protons and electrically neutral neutrons. Okay, so we learned that all the matter is made up of atoms. The first modern atomic theory was proposed by John Dalton. According to Dalton, atoms were indivisible. This means that they could not be divided into further smaller parts. Okay, atoms of all elements are identical to each other and different from atoms of other elements. So why are the atoms of different elements are different? So nature and properties of elements depend on the arrangement of atoms. We know that the different elements behave differently. This is due to difference in their atoms. Is there anything inside the atom that make them to be same or different? Yes, the arrangement of subatomic particles inside the atom is responsible to make them to be a same or different. Are the atoms indivisible? No, atoms are divisible. There are many subatomic particles inside the atom according to the recent experiment. Atoms are too small to be seen with naked eye. Scientists relied on indirect evidence to prove the existence of atom. Since they could not see the atoms, they could find the properties on the basis of experiments. Very soon, they realized that the atoms could gain or lose charges during the electrolysis experiment. Michael Faraday discovered that the atoms were acquiring negative charge during the process of electrolysis. Michael Faraday discovery raised few questions about the indivisibility of atoms. How could a neutral atom become electrically charged? It is a contradiction to Dalton theory that the atom was indivisible. This led to an idea that there must exist some small particles in atom which are responsible for the atom to behave sometimes as a charged particles. As atom is considered as electrically neutral, it probably had some positive constituents and equal number of negative constituents to maintain its electrically neutrality. So this gives a scope to think about the subatomic particles. In science, theories change when the scientists discover new facts or clues. Sometimes an idea or model must be changed as new information is gathered. Dalton proposed that atom could not be divided. Experimental evidence began to show that atoms were divisible and are made up of small particles. Since these particles are smaller than the atom and are present inside the atom, they are called as subatomic particles. Since atoms are neutral, they should have at least two types of subatomic particles. One is positively charged and another is negatively charged. In fact, three different subatomic particles have been discovered. The third one is a particle without any charge. Okay, so this electron, proton and neutron, these three are the subatomic particles. Okay, so if the atom consists of subatomic particles like proton, neutrons and electrons, know how they are arranged in that atoms. So our scientists they explain the arrangement of subatomic particles in atom and they explain different theories. Means you have learned about these theories and you learn about the atomic models suggested by J.J. Thomson, Ernest Rutherford, Niels Bohr in the which have been presented in class 9th. So about the arrangement of these subatomic particles in the atom. Means about these atomic models, J.J. Thomson, Ernest Rutherford, Niels Bohr were suggested. We learn about this in 9th class. On the basis of your previous knowledge, can you prepare a model of an atom? Can you arrange the subatomic particle in any other way in an atom? Do all atoms have the same subatomic particles? Why is an atom of one element is different from the atom of other element? How are the electrons are distributed in the space of an atom? To answer the above question, we need to understand the nature of light, colored flames and their characteristics. Okay, now we will discuss about spectrum. You must have observed the formation of rainbow. How many colors are there in rainbow? There are 7 colors, namely violet, indigo, blue, green, yellow, orange and red. PIBGR. Okay, these colors we can see in a rainbow. Okay, you can find the colors spreading continuously and the intensity of each colors varies from one point to other. Spectrum is a group of wavelengths or frequencies. Spectrum is a group of wavelengths or frequencies. We'll learn about this spectrum in next topics. So the spectrum is a group of wavelengths and frequencies, means band of colors produced by a light into parts with a different wavelength. Okay, so band of colors produced by a light into parts with a different wavelengths. And now we will discuss about wave nature of light. When you throw a stone into a still pond, you observe ripples which are transmitting the disturbance in the form of waves on the surface of a water. Okay, so when we throw a stone into the pond, we will observe the ripples. So these are transmitting okay, which are transmitting the disturbance in the form of waves on the surface of a water. You know that sound waves are produced when something vibrates, like a drum. Yes or no? Yes. Okay, when something vibrates, then sound waves are producing. In the same way, electromagnetic waves are produced when an electric charge vibrate. Okay, so like water waves and sound waves, electromagnetic waves are produced when the electric charges vibrate, means when it is moved back and forth. Okay, so how do the vibrating electric and magnetic fields around the charge becomes a wave that travel through the space? Okay, how do the vibrating electric and magnetic field around the charge become a wave that travel through the space? A vibrating electric charge creates a change in the electric field. A vibrating electric charge creates a change in the electric field. The changing in electric field create a changing in the magnetic field. Okay, so vibrating electric charge create a change in the electric field. The changing in electric field create a change in the magnetic field. This process continue with both the created fields being perpendicular to each other and at right angles to the direction of the propagation of wave. Okay, so a vibrating electric charge create a change in the electric field and changing in electric field create a change in the magnetic field. This process continue with both the created fields that being perpendicular to each other at a right angle to the direction of propagation of the wave. Visible light is an electromagnetic waves and the speed of light c is 3 into 10 to the power of 8 meter per second. Okay, so visible light is also one of the electromagnetic wave and speed of light is 3 into 10 to the power of 8 meter per second. So what are the characteristics of electromagnetic waves? Electromagnetic energy traveling through a vacuum behaves in some way like a ocean waves traveling through the water. Okay, so when the electromagnetic energy traveling through the vacuum, it behaves like ocean waves when the two traveling through the water. Okay, so like ocean's waves, how that are created in the water, like that electromagnetic energy also forms. This electromagnetic energy, when it is travel through the vacuum, it is also behaves like a wave. Okay, so electromagnetic energy traveling through a vacuum, it behaves in some way like ocean waves traveling through the water. Like ocean waves, electromagnetic energy is characterized by wavelength lambda and frequency nu. Okay, so waves, we discussed about the sound waves like that, no? In the sound is traveling in the form of waves. The distance between two consecutive crests are called as wavelength, that is showed by lambda. Okay, the number of vibrations produced per second is called as frequency nu, that we discussed in 9th and 8th classes, no? Like that, like ocean waves, electromagnetic energy is also traveled in the form of waves, no? So that is characterized by wavelength lambda and frequency nu. So electromagnetic energy traveling through a vacuum, it behaves in some way like ocean waves traveling through the water. Like ocean waves, electromagnetic energy is characterized by wavelength lambda and frequency nu. So the wavelength lambda of the wave is the distance from one wave peak to the next. Okay, so means the distance between two waves is called as wavelength, that is showed by lambda. The frequency nu of the wave is simply the number of wave peaks that pass by a given point per unit time. Okay, frequency means the number of waves produced per second is called as frequency. Okay, so it is expressed in units of reciprocal of seconds. So the relation between these two quantities given by lambda is proportional to 1 by nu, or C is equals to nu lambda. Okay, so wavelength is nothing but the distance between two waves is the distance between two waves. The distance between two consecutive crest or throw is called as wavelength, that is showed by lambda. The number of vibrations produced per second is called as frequency, that is showed by nu. What is the relationship between these two quantities? Lambda is C is equals to nu lambda. Okay, or lambda is inversely proportional to 1 by nu, otherwise C is equals to nu lambda. Can we apply this equation to the sound waves? Yes, it is universal relationship and applies to all waves. As the frequency increases, the wavelengths become small. Electromagnetic waves can have wide variety of frequencies. So these electromagnetic waves can have wide variety of frequencies. The entire range of electromagnetic wave frequency is known as electromagnetic spectrum. Okay, so electromagnetic waves can have wide variety of frequencies. The entire range of electromagnetic waves frequencies are known as electromagnetic spectrum. The familiar example of the visible spectrum is the visible spectrum in nature is the formation of a rainbow. Visible light is also an electromagnetic wave. Okay, so the familiar example for the visible spectrum is the formation of rainbow, which is formed in the nature. Okay, so this formation of rainbow, that is one of the example for visible spectrum. Okay, this also one of the electromagnetic wave. Okay, each color in a rainbow is characterized by a specified wavelength from red higher wavelength to violet shorter wavelength. Okay, each color in the rainbow is characterized by specified wavelength. From means red color having one wavelength, that red color having higher wavelength, and violet color also there, that having shorter wavelength. In rainbow 7 colors are there, that 7 colors having different wavelengths. In that red color have highest wavelength, violet color have shorter wavelength. So red color have higher wavelength, violet color have shorter wavelength, and remaining color have remaining different wavelengths. These colors means wavelengths that the human naked eye is sensitive to or called as visible light. So these colors means different wavelengths in a rainbow that is visible to human eye. Okay, so that's why this is called as visible light. Okay, these color wavelengths that the human naked eye is sensitive to or called as visible light. Means in rainbow different colors will be there, no, that are visible to human eye. So that's why that is called as visible light. The range of wavelengths covering red color to violet color is called as visible spectrum. Okay, so here in that visible light, different colors having different wavelengths, no. So the range of wavelengths covering red color to violet color is called as visible spectrum. Okay, spectrum means band of colors produced by a light into parts with different wavelengths. Okay, so the formation of rainbow is one of the familiar example for visible spectrum, and each color in the rainbow is characterized by specified wavelengths. Means in that different colors having different wavelengths. In that red have higher wavelength, violet have shorter wavelength. So these colors that wavelengths that the human naked eye is sensitive to are called as visible light. Okay, these colors human eye can see, so this is called as visible light. So in that visible light, different colors having different wavelengths, no? Yes or no? Yes. So the range of wavelengths covering red color to violet color is called as visible spectrum. So are there any other wavelengths of light other than visible spectrum? So are there any other wavelengths of light other than visible spectrum? Yes, there are another wavelengths of lights also, but different wavelengths are called with different names. Okay. So in electromagnetic waves, different places called with different names. So many electromagnetic waves are there, but their wavelengths frequencies is different. Okay, but their wavelengths and frequencies are different. Okay, so now we will learn about the electromagnetic spectrum. That's about electromagnetic spectrum. What is the meaning of electromagnetic spectrum? The entire range of electromagnetic wave frequencies is known as the electromagnetic spectrum. So what is the meaning of electromagnetic spectrum? Electromagnetic waves can have wide variety of wavelengths. The entire range of wavelength is known as the electromagnetic spectrum. Okay, so electromagnetic waves can have a wide variety of wavelengths. The entire range of wavelength is known as the electromagnetic spectrum. So electromagnetic waves can have a wide variety of wavelength. The entire range of this wavelengths is known as the electromagnetic spectrum. The electromagnetic spectrum consists of a continuous range of wavelength of gamma rays at the shorter wavelength to radio waves at longer wavelength. The electromagnetic spectrum consists of a continuous range of wavelength of gamma rays at shorter wavelength to radio waves at longer wavelength. But our eyes are sensitive only to visible light. Okay, so in this electromagnetic spectrum, different places are called with different names by depending on the wavelengths and frequencies. So like cosmic rays, gamma rays, X-rays, UV rays, IR rays, microwaves, radio waves, broadcast band, like the different places are called with different names. Okay, so these in this some rays are useful to us, like microwaves are there that we can use in microwave oven. IR rays are there that are produced from the electric heater and iron boxes, like that. So X-rays are there that we are using in the treatment, like that. These rays are useful to us. So in this all the rays, our human eye can see only visible light. That visible light also one of the part of this electromagnetic spectrum. So this visible light in this all the electromagnetic spectrum, only visible light is so we can says that visible light is we can see. Okay, so till now what we discussed? We discussed about subatomic particles, which are called as subatomic particles: electron, proton and neutron. These are called as subatomic particles. We discussed about these subatomic particles. So and to explain the arrangement of the subatomic particle, different scientists have proposed different models. In that we learn about the J.J. Thomson model, Niels Bohr model, Rutherford atomic model. Okay, so next we discussed about the spectrum. Spectrum means continuous range of wavelength and frequency is known as spectrum. Okay, the band of colors which have different wavelength, that is called as spectrum, that we discussed. And we discussed about the wave nature of light and electromagnetic spectrum. Okay, so in this electromagnetic spectrum, what is the meaning of electromagnetic spectrum? Continuous range of wavelength and frequencies of a electromagnetic wave is called as electromagnetic spectrum. So by depending on the wavelength and frequencies, in that electromagnetic spectrum, we will call the different places with different names, like cosmic rays, gamma rays, X-rays, UV rays, IR rays, microwaves, like that we can call with different types of names. Next, in this we can see the so when white light dispersed through the prism, that's splitting into 7 colors, means like rainbow colors. That rainbow colors we can see on the screen also. That is called as visible light. This visible light is we can see this visible light, the 7 colors we can see in the rainbow also. We can see the 7 colors. That 7 colors also we can see. That is called as visible light. This visible light also one of the part of this electromagnetic spectrum. Okay, in this electromagnetic spectrum, different places are called with different names by depending on the wavelength and frequencies. No, so this visible light also one of the part of this electromagnetic spectrum. This one only visible to us when we compare with other places.